This is geotrig lesson 18. We have already dealt with word problems where you were told you might have 2 times the number of blues is equal to the number of greens. Now we're going to kick it up just a little bit more and possibly, potentially, introduce a second or third color marble or thing that we're talking about. We're going to talk about many different things going together. We're also going to talk about systems of equations, and we're also going to talk about mixture problems here. Okay? If you follow the procedure, things are going to go very well for you, but if you don't listen and you want to do your own thing, it could potentially have some repercussions you won't like. So, big things here, that if there are 3 different things going in, or 3 different variables, then you need to have 3 different equations. If there's only 1 variable, you need 1 equation. If there are 2 variables, you need 2 equations, and so on. The number of equations matches the number of equations. An equation can be as simple as B equals 2, because the number of blues equal 2. That is considered an equation. It doesn't have to be where you have 5 or 6 things together to make an equation. You don't need 2x plus 3y equals 4. We don't need that type of equation to be considered it. And again, for unique solution, the number of linear equations must be as many as independent equations, or variables. Okay? So, what's the first type of problem? Let's bring back some blues and reds and whites and greens here. So, the biggest problem that most students have for these types of problems is they can't set it up. Once you get it set up correctly, the math usually isn't the problem. It all comes down to, a lot of times, students get mixed up on to be more than, to be less than, because to be more or less than something, and I've said this before, to be more or less than something, you need to know what that something is. Okay, so let's read the first sentence. Usually on word problems like these, every sentence is actually its own equation, for the most part. The number of blues was 4 less than the sum of the whites and greens. Now there's some action words in here. Was, is, and is and was would stand for what? To be something, or to be is, or was, it'd be equal to. So it's an equal sign. So the number of blues, so what we're going to do, guys, is we're going to use B, we're going to use W, and we're going to use G. B will stand for the number of blues, W equals number of whites, G equals number of greens. Yes, I'm running really fast. I'm just trying to show you. Guys, not every single time am I going to list this. Eventually, at some point, we're just going to say, hey, I know I'm just going to let B equal the number of blues, W equal the number of whites, G equal the number of greens. So I could go here. I'll make that a little bit smaller, save ourselves some room. So let's go to that first equation again. The number of blues is, or was, so B equals 4 less than something. And that something is the sum of whites and greens. What does that mean?
Would it be 4? No, that would be multiplied.
WG minus 4.
WG minus 4 is not correct
So
either.
it would be 4 and then the less than sign, GW?
What does the sum mean, guys?
To add them together.
Add them. Okay, think of this. I need to be 4 less than something. The something is a sum. So I need to state the sum. The sum is whites and greens. So I am going to add parentheses and put W plus G. There's my sum. And I have to be 4 less than that, so minus 4. Now, guys, I'm not going to argue with somebody who puts the 4 on the other side, but puts B plus 4. Would that be okay? But then if I do that, then I have to get rid of the negative 4 over here. I could add 4 to both sides, bring the 4 over by the B. That's fine. And then it says also, the number of greens equaled, well, that's easy, equaled the sum of the blues and the whites. Oh, so what would that look like? B plus W. Do I need parentheses around that one? Because I'm not adding or subtracting to the group. That's fine. And then it says how many of each were there if there were twice as many blues as whites. This one also gets kids. Okay? Is this true? B equals W? Which one is there more of?
Blue.
There's twice as many blues. That means there's more blues than whites. How many more blues?
2. So would it be 2B?
It's not 2B, because B has to be bigger than
B
W.
squared. What?
Twice the number of whites as blues. Or 2 times the whites would equal the blues. Because there's twice as many of the blue than there is white.
Oh.
So what are you going to be 2 times more of? The whites. I have 2 times as many quarters as I do pennies. If I have 10 pennies, I have 20 quarters, yes. Whew. Okay. Now, guys, I have how many equations?
3.
How many variables?
3.
You have enough to solve. And it says how many of each. So you need to state how many blues, how many greens, and how many whites. This is all about substitution. You have to be able to get down to one equation and one variable. Doesn't it look like B would be really easy to substitute in right now? So could I go up here and say, hey, I know what B is. B is
2W.
2W. B is 2W. So 2W equals W plus G minus 4. I don't think I need those sets of parentheses either. But then I put it into the second equation here. I'll have G equals, I'm using substitution here, so 2W plus W?
Mm-hmm.
Oh, wait, that's
3W.
3W.
Oh, I get it.
So wait, so can't I just take the G that's in this equation now, take it out and replace it with, because G equals 3W? So 2W equals a W plus 3W minus 4? One equation, how many variables? Different variables. Just one. They're all W's. Can I gather all the W's on one side, the number on the other, and solve? Isn't that 2W equals 4W minus 4?
Mm-hmm.
What do you guys want to do?
Then could you minus the 2W?
How come you guys don't see that up there? Okay, problem is fixed. Which way do you guys want to go with the W's? Okay, we say subtract 2W from both sides. So we get 0 equals 2W minus 4. Add the 4 to both sides. Gone. 4 equals 2W. Divide both sides by Listen, the math usually isn't too bad once you start rolling. But W is equal to 2. We only know the number of whites now. We have 2 whites.
Yeah, you can plug it in. If I
Now you can back walk, right?
No.
Into all of these. Then I could take the 2 from the W and plug it into here to find B. So it equals 2 times 2, which is, so there equals 4. So B equals 4, W equals 2.
G equals
G
6.
equals 6.
And so we could,
Oh my God.
we have options. We have options, guys.
Sorry.
I could use this equation because I know B and I know W, therefore I could find G.
Yeah.
Or, wait a minute, didn't we say G was also in terms of W?
Or just do it that way.
No, that's way too complicated.
3 times 2, which is,
Why would you?
it's a little all over the place here, but, so I'm running out of room. But, not G, not W. Why'd you guys write that, guys?
Why would you put that, Mr. Punch?
It's hard to write.
So, G equals 6, B equals 4, W equals 2. You just solved the problem.
Literally, right there.
Now, you could possibly asking yourself, why would I care about blues, reds, greens, and whites, and all of that, and how many I have? Where's a more practical use of my time? Money. Money, money, money. As they say, show me the money. Name the movie, guys. Show me the money.
You've never
Show
seen-
me the money!
You've never seen that?
You guys don't know the movie.
Come on.
Say it again. Say it loud. Show me the money!
Oh, you want
Come on, Jerry. Show me the money! Come on. You guys don't know this? Whole song on the radio makes you cry. Oh, it's crazy.
Are you recording?
Yes, I am. So,
You guys don't know that movie?
you don't know the movie?
What movie is it?
What is it, Jake?
Jackie Robinson.
You don't know.
I don't know.
Jerry's the main character.
Shut up.
Jerry Seinfeld.
What's that? What
Tom, it's played by Tom Cruise.
Tom Cruise.
Jerry Maguire.
What's the movie?
You had me at hello.
Titanic.
No, that's not. Is that how you had me hello? Or is it Tom? No, that's that movie. Jerry Maguire. Sports. It's a sports movie, guys.
I've seen it.
Cuban Jr.'s in it. What's his name?
Cuba Gooding Jr.
Cuban Gooding Jr.
Cuba
Cuban Jr.
What is his name?
It's a sports movie.
What is his name?
Jerry Maguire.
You don't even know the name.
Okay, guys.
Wait, what's the name of the movie?
Jerry Maguire. Okay, it's on the video. Watch it. It's like 12 times now. Okay. Anyways. Yes, money, guys. You never know when you're stopped in the side of the street and they're like, "Hey, I've got 20 coins for a value of $1.90. How many of each coin do I have?" They might.
Yeah, before I give you money, you gotta answer this question.
Yes. Okay. So again, this problem, guys, talks about money. We have 20 coins total made up of quarters, nickels, and dimes. Their value is $1.90. That's not enough. We need one more piece of information, because it's asking how many of each do I have if there are 4 times as many nickels as quarters. Now we have a complete set of information. So, there's a couple different equations you need to get from here. The first one is, there's a total of 20 coins. So, here's the thing. I am going to let Q stand for what?
Quarters.
Not quarters, but the,
Quantity.
yes, the quantity of quarters. So this would be number of quarters. I would say that
No.
N, yes, would equal the number of nickels, and D equals the number of dimes. What's so special about the quantity of the quarters, the nickels, and the dimes? They equal,
190.
no, 20. So Q plus N plus D is equal to 20. The total number of coins is 20. You can't have more. You can't have less. Now, wait a minute. We also have money. And each one of these is worth money. How much is a quarter worth?
Q times 25.
So 25Q plus
10. Oh, whoa. 0.5,
it's
yeah.
not 0.5 N, it's 0.05 N. Why is it 0.5? It's 5 cents. Plus
0.10D.
0.1D or 0.10D equals
20.
no,
What the heck?
1.9.
Yeah.
There's our second equation. And the last equation, guys, of show me the money is something with N and Q, where N equals Q? No, that's not true. There's 4 times as many nickels as quarters. No, all the way. 4 times the number of quarters will tell you how many nickels there are. Because there's more nickels than quarters. Okay, so if you have 1 quarter, you know you'll have. If I have 1 quarter, I will have what? 4 nickels. 2 quarters, I'll have
8.
8 nickels. Okay?
3. 12.
Ladies and gentlemen, we could work with these equations. I could, again, just like the last problem, I now have a system of 3 equations and 3 unknowns. I could backwalk this or back substitute this N, which is 4Q, in for N, and in for N, get 2 equations, 2 unknowns, and keep going. Yes? How many people want to work with those decimals?
No way.
What's the best way to get rid of decimals? Multiply both sides of the equation by some magical number to get rid of them. And the magical number,
What?
it's 100. Guys, why is it 100 and not 10?
Because 100 gets rid of the decimals.
Because how many decimal places are there?
There's 2.
2. Every time I multiply by a 10, I move the decimal once. So please follow. Q plus N plus D equals 20. But then 100 times 0.25Q is
25.
25Q plus
5N plus 10D equals 200.
equals 190.
Again. Stop. Stop, yeah.
And then N equals 4. Oh, I don't need W over there, I guess. Equals 4Q.
Okay.
Now we have all nice numbers, guys. We have options here. I could technically bring the Q and the N to the same side, and I would have three equations with 3 unknowns. Guys, which allows me to use substitution or linear combination. Or I just use substitution first, like I talked about the first time, by placing, it went away again, in, which is still not working for you guys on the screen, and place it in for N in the top 2 equations. And that's what we're going to do. Okay, so we've technical difficulties. We're just going to continue on here. So what I'm going to do is I am now going to take the N equals 4Q and replace it into the equation. In both of these equations stated above. so that I can eliminate another variable, so I'm down to 2 equations with 2 variables. Simplifying these, I end up with q plus 4q, which is 5q, plus g equals 20. And this would equal 20q plus the 25, which is 45q, plus 10d equals 190. Now, I'm going to switch to elimination or to cancel out our terms. And so to do that, I like multiplying the top one by either a -9 or -10. 10's usually easier to multiply by things by, so I get -50q minus 10d equals a -200. And if I add these together, I get a -5q. The 10d's cancel, equals -10. Divide both sides by -5. And so q equals 2. Now that I got q equals 2, I am going to place it back in the equations where we had just 2 variables, which would be the 5q plus d equals 20. So 5 times 2 plus d equals 20. So 10 plus d equals 20. Subtract 10. So d equals 10. We know we have to have 10 dimes. To find n, if you remember back, n is equal to 4q, which means 4 times 2, which is 8. So I have 8 nickels, 2 quarters, and 10 dimes. Homework is page 136 of lesson 18, day 1, and 1 through 2, 9, 21. Have a fantastic day. Got a little rowdy today. It's alright. Show me the money.